Hello everyone, Mr. Minix. My name, math is my game. Today, October 4th, I'm joined by my favorite first period Algebra II class. I've had first period Algebra II for 15 years, and seriously, this is my favorite group so far. So, we're looking at Chapter 3, Section 6 today, and in doing so, we're going to kind of take a trip down memory lane. 3.6 is titled Solving systems, and when we say systems, we're talking about systems of linear equations. Actually, in this particular section, they go into bigger systems. They go into three-dimensional systems, which we might look at one or two. But solving systems using what we talked about the last couple days in class, using matrices. A lot of people don't like when I mispronounce words, but that's the way it's spelled, matrices. So. The reason we do this is because the Common Core Content Standards say so. If I look in my book, I could actually find that Common Core Content Standard. It is A.REI.8. The students will represent a system of linear equations as a single matrix equation and a vector variable. Say that again. Okay. So trip down memory lane. A while ago, we solved by graphing y equals x minus 2 and y equals negative 2x plus 7. Hey, that's the system that was on the quiz, isn't it? Well, we probably ought to look at how to use the graphing calculator to solve that, because in a couple days' time, you're going to be taking a chapter test, and I would like you to have that skill set to be able to use the calculator and solve a system and get the answer using a calculator. So let's go to the calculator. The TI-Nspire is like a computer in several ways. One way it's like a computer is if you turn it off and turn it back on, it kind of resets everything. When you press the home button, notice at the top of the screen, see there's a home button on the top right? That home button is the on button. Those top 6 buttons are kind of important. The ESC, the escape button. If you're in a screen and you want to back up a screen, you hit the escape button. The button on the left-hand side, the second one down, the scratch pad, I'm not a fan of it, but it is handy in certain circumstances, but we're not going to use the scratch pad. So I'm going to use my directional pad, and I'm going to arrow over and click that X to close out of that. Or I could even escape to get out of the scratch pad, I think. Yeah, escape works there. Tab is handy when you're cycling from one box to the next. Doc, we're going to use quite a bit today, and menu, we're going to use a lot today. So what we're going to do is we're going to start a new document, if you haven't already. And we're going to go, first of all, to a graphs page. Okay? Everybody there? So the first thing I want you to notice is, at the top of the screen, do you see the little tab at the top of your document? What's it say? What's that little tab say? It has a label on it. It says, unsaved, but the little tab at the top left. 1.1, that means it's the first problem and it's the first page. What I could do, and you don't have to do this, but real quickly just to demonstrate, I'm going to hit Doc, insert a calculator page. I'm going to hit Doc, insert a problem with a graphs page. So now you'll notice my tabs have a 1.1, a 1.2, and a 2.1. So my first tab is problem 1, page 1. My next one is problem 1, page 2. My next one is problem 2, page 1. You can actually go into a slide sorter view if you press Control and up, and you can jumble the slides around, you can move them around, and you can select a particular slide from this slide sorter view. Okay. So anyway, if I wanted to undo all that, anybody know how to undo something on a computer? Control Z. You don't have to hold Control, but if you press Control Z, and Control Z again, and Control Z again, and Control Z again, and you just keep pressing Control Z, Control Z, Control Z, it keeps undoing that which was done. Control Z, Control Z. Okay. So anyway, we're going to put in the first equation. I think it was y equals, we have f of x, that's fine. Y equals x minus 2. So x minus 2, we press enter, and the calculator graphs that line. So far, we're doing all right? So let's go ahead and add the second function. Does anybody recall how to get to the command line so that we can add our next function? Tab, good. Tab. So we press tab and we enter our second function. The second equation we're looking at is y equals negative 2x plus 7. The nice thing about the Nspire, it's pretty forgiving. What I mean by that is if you inadvertently put minus 2x plus 7, I think it'll let you slide with that, okay? Yeah. So wouldn't it be nice if we could turn on in view grid lines? How do we do that? Somebody said it. Menu, yeah, is it 263? Menu 2, view, 6 grid, 3 lined grid. Awesome, menu 263. So that kind of gives us an indication that our intersection point occurs somewhere around 3, 1. Now, if we wanted to be sure, we're going to have to use our special eyes. We're going to press menu. We're going to press sticks, or anal eyes is what we're going to use. And we want to find the point where the graphs intersect. So option 4. Now this is the part where a lot of people struggle to use the calculator and they just give up and they just want to get rid of it. The calculator's asking you a question. It's saying lower bound, question mark. It's saying is the little pointing finger to the left of the intersection point? Is it? If it is, go ahead and press enter. So it is. My vertical line right here is to the left of the intersection point. So I'm going to press enter, and that sets the lower bound. Now it says upper bound. In other words, is that vertical line to the right of the intersection point? Well, no, it's not. So I need to move that line over. And once I do you see how once I do, the intersection point appears? And then I'll go ahead and press enter for my upper bound, and there we have 3, 1, the solution. Okay? Questions, comments, concerns, short debates about that? Going once. Going twice. We're going to look at another one. Okay, what I'd like you to do then, hopefully you're following along. Everybody doing this on their calculators, I hope? Okay. On Friday's test, I'm not going to show you how to use the calculator during the test, so I would be taking notes, jotting things down, doing this step by step. So I'm going to go doc, and I'm going to insert a new problem. And again, I'm going to be using a graph page, okay? My computer sometimes gets a little carried away, but I'm inserting a graphs page. The reason I did that is I like to go back to f1 of x. So the next system I'd like to try to solve is a little bit different, and we are going to solve it by graphing again. This one's going to have a standard form equation. In addition to our slope-intercept form equation. So we're going to use that system. I think it's probably going to be easier to enter the slope-intercept equation, huh? Because we're already set up for that. Y equals x plus 6. So f of x equals x plus 6. Everybody with me so far, I hope? I'll press enter to graph that. Now, I don't know if your algebra teacher has shown you this, but the TI-Nspire has the capability of graphing. So the TI-Nspire has this ability to graph a standard form equation. I'm not sure what to do, though. If I'm not sure what to get at Wendy's, what do I look at? The menu. So I'm going to look at the menu again. Now, I need to somehow graph something. I need to enter the equation of the graph. So where do you suppose I would go to enter the equation of a graph? Graph entry edit. Graph entry edit. Now, the previous notation, function notation, is not going to work. But I do want to enter the equation. I do want to enter the equation of a line. So what do you think I'm going to choose now? Yours is different? Your operating system? Are you able to get to it? Let me. Okay. Some of the operating systems might be a little bit older, but you should still be able to do this. Can you go to equation? And then equation of a line? And then does it have an option for line standard? Okay. So now it's asking us for our coefficients. Well, the equation was 2x minus 2y equals 4, so my coefficient of x is going to be 2. And remember that button I said that's handy to cycle from a box to the next box, the tab button? I like to use the tab button. So 2x plus negative 4y, and that, no, it was negative 2y, I'm sorry. So plus negative 2y, and that equaled 4. And I go ahead and press enter, and it can graph that too. It can graph that too. Oh, what do we notice about those lines? There's no solution, they're parallel, they're not going to intersect. Okay. Any questions about those first two systems? Do we feel like on a test, if we were asked to solve by graphing, that we'd be able to successfully use the calculator to help figure it out what it is? Okay. I think, like we did on that last problem, turning on the lined grid is really a big help, right? Especially if it works out nice. Okay. Well, what we need to look at next, so this was solved by graphing. So this was solved by graphing. So we solved by graphing using the calculator. Next, we're going to look at solving algebraically. So solving algebraically, if we look at this system, 2x plus 7y is 4, and 3x plus 5y is negative 5. And we had to solve that algebraically. Does anybody recall what technique might be nice to do? Graphing, substitution, elimination. Elimination, right? Both equations are in standard form. Now the deal is, our x's don't have the same coefficients, do they? And our y's don't either. So we would have a lot of work to do. We would probably have to multiply this by negative 3 and this by 2, so we get negative 6x minus 21y is negative 12, and 6x plus 10y is negative 10, and so we get negative 11y is negative 22. So we get y is 2, and x would be whatever x is. 2x plus 14 is 4, so 2x is negative 10, so x is negative 5. Right? That's a lot of work. I showed you this last week, but we didn't do this on a calculator, so let's do it right now on the calculator. On the calculator now, what we're going to do is we're going to insert a calculator page. We're going to go insert a calculator page. So how do I do that? Into my document. How do I insert a calculator page into my document? Into my document. Doc. If I want to change my document, I go doc, and I want to insert, option 4, insert a what? We're going to do this from a calculator page. So we're going to do this from a calculator page. Now, who likes to have a step-by-step guide? I know I do. So to get the step-by-step guide, we don't know where to look, so we're going to go to the menu. What class are we in? Algebra, varsity math. So we're going to go number 3, algebra. And we're trying to solve a system of linear equations. What option do you think we're going to pick? 2, solve system of linear equations. We have 2 equations. We have 2 variables, x and y, separated by commas. Okay, so we're going to hit OK. And the nice thing about this, we don't have to change the form of our equations. We could just punch them in right as they are. So we'll just type in the equations. 2x plus 7y is equal to 4. Remember, if you need to get down to that next box, pressing the tab button is nice. I didn't put my plus in. 2x plus 7y equals 4. And 3x plus 5y is equal to negative 5. Once you get that, you got to be kind of careful when and where you press enter. You probably want to arrow all the way to the end of that expression prior to pressing enter. Okay. So you go linsolve, put your equations in, and you press enter, and what do you get? You get the solution really fast, don't you? Did it pop up on yours? Negative 5, 2. Negative 5, 2. Okay. Are there, question. When you go to put an equal sign, you're getting a syntax error. Can you bring your calculator here? I'll take a quick look. So a lot of times the calculators don't do what we want the calculators to do. I press the equal sign. Right there. Oh, Okay. Anybody familiar with our computer teacher here at the school? I'm going to give a shout out to Mr. Bartz. I like what he says. He says, you know, a lot of times machines will do what we tell them to do. And if we don't tell them to do something, they're not going to do it, right? So what happens, you'd be amazed at how many calculators I see where this happens. Somebody will enter this equation. They'll enter 3x plus 4y. We're going to look at another one. 3x plus 4y equals 12. And they'll press enter, and they're like, oh, I don't know what to do. Well, you're not doing the right thing. But the calculator is supposed to do, well, you didn't tell it to do anything. You got to tell the calculator what to do. So again, you got to go menu, algebra, solve systems. Okay, and then you got to enter your equations. We'll try another one real quick. 3x plus 4y is 12. 3x plus 4y is 12. And then our other equation is y equals negative 2x plus 10. Y equals negative 2x plus 10. And we can solve that system pretty quick. Well, it was supposed to be 2x plus 10. I put 11. Sorry. Oh, copying and pasting. Does anybody know how to copy and paste on this thing? You just have to go up. You use the directional pad and you just scroll up until it's highlighted, and then what? Just hit enter, and then it copies and pastes instantaneously. So I needed to change that 11 to a 10, and whoop, there it is. Okay. Are there any questions about anything that we've seen up to this point about solving by graphing or about using this linsolve? Friday's test, 3 pages, multiple choice, a lot of it, short response on some story problems where you're probably going to have to write a couple of systems about t-shirts or coffee cups.
Teachers, at this time, if we could have 10th grade, A through M, that's 10th.
So anyway, Friday's test, 3 pages, 1 page, solve by graphing. Another page, solve with algebra. Another page, solve by matrices. So that's what we're going to look at today then, solve by matrices. So let's look at that one system from a minute ago, solve using matrices. This is what we were trying to get to today, solve using matrices. So the system is 2x plus 7y. 2x plus 7y equals 4. And 3x plus 5y equals negative 5. We need, first of all, to be able to put that into a matrix. We need to be able to put that system into a matrix. Now, if you had to take a wild guess as to how big of a matrix we're going to put that into, what would you say its dimensions are going to be? A 2 by 3, because there's 2 equations, and there's 3 numbers in each equation, 3 coefficients, if you would. So let's think about this. Both of these equations are in this form, standard form, right? So the deal is our A value, our B value, and our C value, those are numbers. Those are numbers. Those are this 2, and this 7, and this 4. And what we're going to do in this matrix is we're going to be just plugging in those numbers into the matrix. I can't stress that enough. When we do this into a matrix, we're just putting the numbers in, just the coefficients. So our matrix A is going to look like this. The top row is going to correspond directly to that first equation. This equation will be represented by this top row. So guess what that top row is going to have in it? A 2, and then a 7, and then a 4. So what that part right there says, what this says, is that we have some kind of equation, 2x plus 7y equals 4. That's what it says. Or maybe 2a plus 7b equals 4. Or maybe 2m plus 7m equals 4. Make a little bit of sense so far? Okay. All right. So then let's go ahead and do the same thing with this second equation. What's our second row of the matrix going to look like? 3, 5, and negative 5. Okay. How's everybody feeling so far? All right? Well, before we solve using matrices, I kind of want to go to Spanish class for a moment. ¿Cuántos años tienes hoy? How old are you today? How many years do you have today? Yo tengo 40 años hoy. Mañana voy a tener 41 años. Mañana será mi cumpleaños. ¿Verdad? Sí, muy bien. So, what I'm getting at is we need to go to interpreting something. So suppose we had this matrix. Suppose we had this matrix. We had a matrix that looked like this, a 1 and a 0 and a 51, and a 0 and a 1 and the meaning of life. Suppose we had that matrix. Can somebody tell me what that matrix tells us about the variables x and y, or a and b, or p and q, or r and s, or m and n? If they're both 1? Not exactly, no. Is it x equals 1 and y equals 42? Well, let's think about that for a minute. You're probably right. That top row, if we translate that back into an equation, would tell us what? That 1 times x plus 0 times y is equal to 51. And that second row would tell us that 0 times x plus 1 times y is equal to 42. If we simplified each of those equations, the top equation would simplify into x equals 51. And the bottom equation would simplify into y equals 42. So yes, shout out to Kyle. Brought his A game today. So the solution to the system is 51, 42. How do we feel? Does that make sense? Do we get interpreting that, going from that matrix with the 1 and the 0 in it to our solution? So let's try another one. Suppose we had something like this. Suppose we had something like 1, 0, 10, 0, 1, negative 4. What would our solution of our system be? Our solution would be 10, negative 4. How's everybody feeling? The deal is the element in the top right, because of this whole first equation says 1x plus 0y equals 10. We got a comment. What if there are 4? Well, if there were 4 numbers in the top row, we'd be dealing with a 3-dimensional system, and we'd have a 3x4 matrix, and we're going to look at one of those before the class is over, I'm sure. Okay, really good question. So back to this. How did we get the 10, negative 4? This top row says 1x plus 0y equals 10. Simplifying, we get x equals 10. And when we write our answer, remember, it's an ordered pair, x comma y. We feeling a little better about that? Okay. Let's try this. What if we had 1, 0, 8, and then 0, 0, 0? Let's think about that. What did we obtain here in this second row? Oh, we obtained something. Hold on a minute. We got 0 equals 0, which is an identity. Remember what that told us when we solved using algebra? Using the special systems like you're supposed to do on Friday's quiz, discussing the special systems. When you get an identity equation like 0 equals 0, what's true of the original equations? There was many solutions. We had overlapping lines. Remember that? Okay, so this would be one of those deals where we have infinitely many solutions, where we have the same line. Okay, and we'd have to go back to the original equations to see what that looked like. Finally, on those special ones, if we had 1, 0, 5, and 0, 0, 1, what would the implication there be? 0 equals 1, which is false, which means we have parallel lines and there's no solution. Okay? But otherwise, if that doesn't happen, we got a situation like this. Everybody kind of get that, I hope? Okay, so the question is, how do we take our matrix, that 2, 7, 4, 3, 5, negative 5 matrix, and get it into that form? That's the question. It's matrix magic. It's matrix magic. There's this idea, I'm going to go ahead and copy this matrix. Copy all this stuff and paste it onto a new page. There's this idea called reduced row echelon form. Reduced row echelon form. And what it looks like this. It looks like there's a 1 here, and a 0 here, and a 1 here, and a 0 here. And then it's going to put some number here. Who knows what? Some number. We don't know what it is, and another number here. But that's what reduced row echelon form is. The cool thing about the Nspire is it's very capable. It's very capable. You can tell it to do things, and it will do those things for you. You could tell it, hey, put this matrix into this form for me, and it will. You need to give it a command. And that command goes like this. R. You see where that R comes from? R. You see where that R comes from? E. See where that E comes from? F. So this right here, what I'm about to show you, this is the command on the calculator. The command on the calculator is to RREF. And then we're going to have to put a left parenthesis in. And then we're going to have to put our original matrix in. We'll have to put our original matrix in. So what was it? It was 2, 7, 4, 3, 5, negative 5. So that's what we need to enter into our calculator. If we do that, we'll be able to use the calculator to solve systems, and it's awesome. It's real easy. It's real easy. How do you put a matrix into the calculator? Well, we got to figure that out. So here we go. Ready? Let's start with the RREF. Just type it in. R. E. Watch what happens when I put the F in. Do you see how the letters are italicized? Once I put that F in, it goes to not italicized because that's a recognized command. Okay, so RREF left parenthesis. Now the question is, how do we get a matrix? How do we get a matrix? Well, what do artists do when they want to get some paint onto the canvas? Where do they go? To the palette. So let's go to our math palette. The button next to 9. The button next to 9 is our math palette. The button next to 9. Oh! Do you see there's a couple of matrices there? There's a 2 by 2, there's a 1 by 2, and there's a 2 by... You got to use the 3 by 3, and it'll prompt you to change the dimensions. So you've got to go to the 3 by 3 matrix, and the calculator will prompt you. It'll ask you, what are the dimensions? Well, what are the dimensions of the matrix we're looking at? A 2 by 3. So we need to change this to a 2 by 3. So we need to change this to a 2 by 3. However you go about doing that, just make sure 2 rows, 3 columns. My computer got a mind of its own there for a second. I'm going to hit OK. And once I do, notice it puts a 2 by 3 matrix, and I just got to plug in numbers. So what am I plugging in? A 2 and a 7 and a 4 and a 3 and a 5 and a negative 5. And I press enter. And so what is our solution? Negative 5, 2. So the deal is, if we're going to solve a system using matrices, what kind of form should the equations be in? The equations have to be in what kind of form? Standard form, right? The equations got to be in standard form. Should we try another one? I think we better try 2 more. 2 more. You ready for this? You ready for this? 1 more. Well, 1 more two variable system, and then 1 with 3. So let's try this one. Let's try x plus 4y is negative 1. X plus 4y is negative 1. And 2x plus 5y, 2x plus 5y is 4, So how do I go about starting this? What do I do? Put it into a matrix? No, I don't think I'd put it into the matrix yet. REF, I just type R, EF, left parenthesis. How do I get my matrix? Hit the math palette button, go to the 3 by 3, make it a 2 by 3, and we enter our coefficients. What are they? 1, 4, -1, was it? Okay, and then 2, 5, and 4. And we go to the end of that command line and we press enter. So what's our solution? 7, -2. Could we do this with the three variable system and find out what A, B, and C are? Let's try that. Let's try a 3 variable system and then that'll be it for the day. I guarantee it. I guarantee it. All right. 2a plus 3b minus c. Oh man. 2a plus 3b minus c equals 1. -4a plus 9b. -4a plus 9b. My a's and b's look alike. Plus 9b plus 2c is 8. Plus 2c is 8. Plus 2c is 8. And -2a plus 2c, -2a plus 2c is equal to 3. So before we go looking at our calculator, we got to think about that last row of the matrix. A lot of people are going to screw it up. Don't be the one that screws it up. What's our matrix going to look like? Our 3 by 4 matrix. We know our top row, don't we? What's our top row? 2, 3, -1, 1. No problems. What's our next row? -4, 9, 2, and 8. That last row, be real careful. Remember, the second column is the coefficient of B. Think about it.
Teachers, at this time, if we could...
That second column is the coefficient of B. So what's my last row going to look like? -2, 0, yes. 0 and then 2 and then 3. So let's go ahead and plug this into the calculator and see what happens. Hopefully you guys have that written down so we can read it off. Okay. So we're going to do an RREF again. RREF, parenthesis, a matrix, a 3 by 3, but we're going to make it a 3 by 4 this time. We're going to make this a 3 by 4. And what was our elements? 2, 3, -1, 1, and then -4, 9, 2, what? 8, okay. And then -2, 0, 2, 3. So I'm going to go ahead and solve this. So what's my A and my B and my C? A is, hold on a minute, what's A? That's not what my A is a half, B is 2/3, and C is 2. So if we were writing our answer as an ordered triple, our answer as an ordered triple would be 1/2, 2/3, 2. This is our A, this is our B, this is our C. What do we think? We got it? You'll have about 8 to 10 minutes in class here to work on it. It's been real, it's been fun. I hope it's been educational. See ya.